Hello all. In this tutorial I will implement a simple assembly line balancing problem in CPLEX OPL and solve a numerical example. The version of this assembly line balancing problem is called type 2 assembly line balancing problem, in which the number of stations is given to us and the precedence relationships between the tasks, and of course the number of tasks and their task times are given to us, and we want to assign these tasks to these workstations to minimize the cycle time. If we have a look at the input and output of this model, so we can say that if this is our model, we know the number of tasks, number of tasks, and this will be an input into our model, and also the number of workstations, we know these number of stations. Let me just write, and then we know the task times, and also we know the precedence relationship between the tasks. So these are given to us, these are input to our model, which means that these are parameters of the problem, and the output of this problem, the model, will be the decision variables, the assignment of the tasks to the stations, and also the cycle time. These will be the output, and which means that these are our decision variables. So if you look at this example over here, the numbers on each of these, first of all, each of these nodes represent the tasks. So in this example we have a total of 12 tasks. So the number of tasks is 12. And also for this example, the number of stations is equal to 5. So this is also given. The task times are written on each at the top of these nodes, so these are the task times, and the precedence relationship here is given as these arcs. So this arc over here represents the precedence relationship between task 6 and 7. It means that task 6 and 9, it means that task 9 cannot be processed earlier than task 6, or task 9 cannot be assigned to a workstation earlier than task 6. Task 9 cannot be assigned earlier than task 6. So this is the formulation of the problem. The decision variable that we define is xji. It's a Boolean decision variable, and it takes the value of 1 if task j is assigned to station I, and otherwise it takes the value of 0. So this one over here is xji, and also the cycle time will be denoted as tc. On the other hand, the number of tasks, number of stations are given. The task times, we will represent them by tc, and the precedence relationship, we will take this as a parameter, as a matrix, and we will represent it as bjk, and this is a 0-1 matrix. So for example like this, and this is task 1, 2, 3, 1, 2, 3, and according to this precedence relationship diagram over here, you see between task 1 and 2 there is no relationship, so we will write a 0, but between, for example, 1 and 3 we have a relationship, so we will write here 1. Between 1 and 1, of course, there will be no relationship. Okay, so it's a matrix consisting of zeros and ones. Basically, we will convert this into such a matrix. And the formulation of the problem is basically we want to minimize the cycle time, in which this cycle time should be greater than or equal to the station times after the assignments are made. So for each station, the cycle time should be greater than or equal to these station times, which means that the cycle time will be equal to the station time of the bottleneck station at the end. And this constraint says that we need to assign each task to one of the stations, and this constraint here satisfies the precedence relationship. Okay, so let's implement this, but in order to implement this, I want this CPLEX to take this data from an Excel sheet. So we will first prepare an Excel sheet, and then we will implement this model in CPLEX OPL so that the data is uploaded from this Excel sheet. So let me open an Excel file. Okay, just waiting for Excel file. Just a blank Excel file, and I will save this file to somewhere in the computer. So let me select, for example, this one. So this will be my project folder, and I will give a name to this. I will say ALB assembly line balancing data.xlsx. Okay, so this is the data, and here it's not needed, but I am going to rename this sheet as data 1. Let me see. Maybe you may want to include more sheets on this, so you can keep the data on different sheets and read them from these different sheets. So on this first data, remember, we need to have all these input, all these parameters inside this Excel sheet. Okay, so first I'm going to write the number of tasks. So let the number of tasks be written here. I will write n tasks here. Of course, you don't need to do this. But I'm writing this to make it more readable. And the number of tasks in our case is 12. Okay, so just 12 is enough for you. But in order to understand what it is, I have written here number of tasks. And here I will write the number of stations and stations, and in our case the number of stations is 5. Okay, now we need the task times and the precedence relationship. So I will write the task times to here simply like this, tasks, let me say, and here the times, tj. Okay, so 1, 2, 3, and we have up to 12 tasks. Okay, and we need to write their tj values. So basically I will copy this one here to this Excel so that we can see the figure and fill in those task times. The task time for the first one is 0.2 minutes, the second one 0.4, and the third one, so I will fill out all of them. The 11th one is 0.5 and the 12th one is 0.12. Okay, so these are the task times. Let me save it, and I will not write the precedence relationships to here, but I will write the precedence relationships to the second page. Again, you don't need to do this. You can write this into the first page also, but I want to show you how you can read the data from different sheets of the Excel file, and also maybe it's better to keep these matrix two-dimensional variable in a separate sheet. Okay, so therefore I will write the data here. So again, it will be task by task, so 1 up to 12. So this is a 12 by 12 matrix, and again I will write it here, 1, 2 and up to 12. So let's a little bit make these rows a little bit narrow. Okay, so initially I will fill every one of these with zeros, because most of these values will be 0. Only a few of them, several of them will be ones. Okay, so it will be easier to write in this way. Between 1 and 2 it is 0, so let me write 1 and 3 is 1 from this diagram. 1 and 4 is 1, and that's all for 1. What about 2? 2 and 4 is 1, and 2 and 5 is 1. For 3, 6, 3, 7, and 3, 8. With 4, 8. With 5 and 10. With 6, 9. With 7, it's 9. And with 8, it's 9. With 10, with 9, it's 11. And with 10 it's 11, and with 11 it's 12. So this is the data. So in order to make it more readable, again you can fill these cells with colors. Of course it is not required. Again, it's for easiness, for reading them easy later on. So this is the Bij values. Let me write here again Bji. And here we have the task times. Task times are written here. I will make it color. And the number of tasks and number of stations are here. So this is our data file. It's ready, and we can start the implementation in CPLEX OPL. Okay, so this is OPL, and the first thing that we will do is to create a new project. So from here, file, if you click on it, click new, and from here select OPL project. It will ask for a name. We can write, for example, ALB trial. You can select the project location from here, otherwise it will save it to a default location. Okay, I will select a location for this. Yes, from here. Sorry. Okay, I will set my project folder to this path. You can select anyone. Okay, yes, you can add a description, but it's not necessary. And from here, to make our job easier, we will need a run configuration, we will need a model file, and we will need a data file. So if you select these, and when you click finish, it will create these files automatically. Okay, so CPLEX OPL now prepares our project. Computer is a little bit slower. Okay, we are still waiting. Okay, so as you see, this is the name that we give to our project. This is a default run configuration, and inside it we have this model and data file, and as you see, the model and data files are currently empty. So let's get started let's start implementing our model into this model file. So again, remember, the input, the parameters of our model are these. So first we need to define these parameters: number of tasks, number of stations, task times, and precedence relationships. Okay, so I will first define the number of tasks, and the number of tasks is an integer, so I will define it as int n tasks. So this is the name that I give to this one. Okay, and you can write this is equal to, for example, 12. And this is how we define the number of tasks with 12 variables. But I don't want to write the data into this model file, although it's fine, it's okay. I don't want to write it here. I want to take all the data from the dot file and from the Excel file. And for that reason, you just write 3 dots, and this tells your model file to take the data from the data file. And here, if you like, you can write a comment by starting the comment out with these double slashes, and you can say number of tasks read from the dot file. Okay, so it is better if you write such explanations for others to read your model later on easily, and for yourself when you want to read it at a later time. The second one will be the number of stations, and again I will write it as n stations, and again I want this to be read from the data file. Okay, I will not write these explanations here. Okay, this is the second input. We need the third input, which is the task times. But be careful, if you look at our data file, the number of tasks is just one value, 12. Number of stations is just one value, which is 5. But on the other hand, this task times, as you see, it's not just a single value. There are 12 values. There are values as many as the number of tasks here. So we cannot just say it is just an integer. We need to define to the model file that it is an array, it's a vector. Okay? And to do this, we first need to define the length of that array. Okay? And if you like, there are many different ways. If you quickly do it, you can just write like this. The values of these task times are not integers, so I will use this float type, and I will give the name t, and you can just say that this t goes from 1 up to number of tasks. Okay, and the data of this will be read again from the Excel file. Sorry, I have a typo here, number of tasks. And also you need to be careful with the uppercase, lowercase letters. This is perfectly fine. And also, if you like, even you don't need to define these number of tasks, and you can just say float 1 to 12. It's also fine. But when you do this in this way, later on when you write your constraints, when you write your objective function, again you will always write this goes from 1 to 12, 1 to 12. Every time you will write it that it goes from 1 to 12. And also when you want to solve another example of assembly line balancing, and in that case if the number of tasks is not 12, but if it is 30, if it is 50, then you need to go into this model file and replace every occurrence of this 12 with 50. And you don't need to do that. In fact, if you just use these n tasks, 1 to n tasks, and if you just say it's 12, then everywhere in the model it will be used as 12. So it is easier to do this, therefore we use it n tasks. And again, since we don't want to repeat these 1 to n tasks all the time, I will just take it and define it as a range. Okay, range, and I will give a name to this range. This is the range of tasks, and I will say this range of tasks goes from 1 to n tasks. Okay, now what I did, instead of writing this part everywhere in my model, I defined it as a name, tasks, and now I will use that name. Okay, so what happens whenever the model sees these tasks, it replaces it with this one. Okay, it's easy, it's for our own convenience. And also, instead of a range, you can define these tasks as a set. Okay, and you can define this, use this sets or set, I don't know, I don't remember currently the notation, but you can define it as a set. For example, stations, and then you define what is inside these stations, 1, 2, 3, and etc., all those elements. Again, this is another method that you can use in CPLEX OPL, especially if your data is not numbered. If you want to use the exact names, for example, the days of the week, Monday, Tuesday, Thursday, you can assign them into these sets, and you can just use their own names in your model. But here, since our tasks are numbered and they are sequential, that goes from 1 to 12, so it's convenient to use this range. Similarly, we define these tasks, we will also need another range to be used for the stations, because if you look at our model here, you see we are writing this constraint here for all stations that goes from 1 to n. This is number of stations. Okay, so for that reason I also need another range, and I will define this as the range of these stations, and it goes from 1 up to n stations. So when you are writing these model file, it is better to write it together with the data file so that no data will be missing. Therefore, I'm going to write this data file at the same time. So how can we write these? Look, the first data file, the first data that I'm going to read from data file is n tasks. So you can just say n tasks, okay, equal to 12. You don't need to say again that this is an integer and etc. We made that definition in the model file. Just use the name and just assign its value. And this is perfectly fine, but still I don't want to write this n tasks or any data into the data file, but I want to read all data from an Excel sheet. And for that reason, we first make a connection with our Excel sheet. Remember, we previously prepared our Excel sheet, and the name of this Excel sheet is this ALB data XLSX. Okay, so I am going to read the data from here in the data file. Therefore, first I need to make a connection with this data file. Okay, so the command for this connection is called sheet connection. Okay, then we give a name to our Excel sheet. So you can give any name here. I will just call it sheet. And now I am going to write the name of the Excel sheet that I will make a connection. It is ALB data data.xlsx. So you need to write this file correctly, the file name correctly, otherwise it will not be able to make a connection. But we haven't written this address, the path of this data file, of this Excel file. Where will CPLEX find that file? So the easiest method, I think, is to save your Excel file inside your project folder in CPLEX. And where is your project folder? How you can find it? Just right click here on the name of your project, right click and come to these properties, and here you will see the location of your project file. In some versions of CPLEX you will see this button here. If you see it, you can click to go to that folder. If you don't see it, just copy this address and just open any file explorer, and on this address bar paste that one, and you will come to this project folder. You see currently in my project folder I have this mod file, dot file, and two other files that this CPLEX needs, and currently my Excel file is here. So I need to move that Excel file to there. Therefore first I am closing this Excel file and I am moving that inside it, and you see now inside my project folder I have this Excel file as well. So now I am reopening the Excel file to see what's inside it, and while it's being opened we can come to this data file, and now currently, since they are under the same project folder, when I give the correct file name, this CPLEX will make a connection. And assume you have a second data file, and in that case you can use these two data files at the same time, and for the first one you can give the name sheet 1, and for the second one you can give the name sheet 2, for example. And the first one, let's say it's the name of the first Excel file is ALB data XLSX, and let's say that this is the second Excel file, and now you can use these two Excel files at the same time. Copy some of the data from the first Excel file and some of the data from the second one. But in our case we just have a single Excel file, therefore I will use it. And this end tasks, now we made a connection, and I need to read these end tasks from this sheet. And where is that number of tasks is located? You see here it's in data 1 worksheet, and it is in cell A2. Okay, so here I need to give that address to the CPLEX. So I will say end tasks from, so this is a saved word in CPLEX, and I will write sheet read, again this is a saved word, and sheet read from where? From this worksheet. So the name that I have written here, I am writing it here, sheet, and in that sheet, where is it? It is in sheet data 1, worksheet data 1, and this is the notation to do it, and cell A2. Okay, so look, it is in sheet data 1, cell A2. Okay, so if I write it in this way, this is the connection, and this is how we read it. There are of course other ways to do it. This is one of the easiest one, but another easy one is to format this Excel file and make use of some properties of this Excel. So what is that? If you go to this formulas tab in Excel, you can define names to these cells or ranges. Okay, so you can use this define name property, or you can use this name manager to manage all the names inside your Excel file. So I will define a name, and the name that I am going to give will be n tasks. Okay, so let me delete this one. It will be n tasks, and it will refer to data 1 A2. Okay, I will click OK, and I will save the file. Now we define the name, and look, when I click on here you will see it is cell B2, but when I click on this one, you see it is N tasks. It is the name that we defined. And again, if you go to this name manager, you can see all the names that you already defined. You can edit them, you can add new ones, and you can delete them. And when you define these names, basically what you can do in this CPLEX is, instead of saying data1 A2, you just write N tasks, the name that you defined here, and CPLEX will automatically read that data. Okay, secondly, we are going to read this N stations. I'm copying this name, okay, N stations, and I'm copying this one and pasting it to here. Okay, so it is not N tasks, of course. We need to read it from this Excel, from this B2, and I'm going to define it. Basically, to define that name, you can just click on here and say N stations. And you see now it is defined as N stations. And let me save the file, and here I will write N stations. Okay, what else? We need to define now this task times. We already defined it, so its notation is T tasks, and now we need to read it from Excel. And when we come to this one over here, I will write T tasks. But when you have such vectors or arrays, you can see the difference in their definitions. You see, when you have just a single element, you just say N tasks. But when you are defining a vector or array, you write inside the parentheses the range. Okay. So, but when you are reading the data from this in this data file, you don't need to write this range again. You just write the name, which is T, and the T will come from again the sheet. But in this case, as you can see, we are not reading just a single cell, but we are reading all these cells. We need to read all these cells. So how can we do? Again, you can do different ways. The first way is to do like this: data1, okay, and it goes from B6 to B17. So you can say B6 to B17, and when you have this notation over here, it defines a range. And again, in fact, we can define a name to here, and we can say, for example, task times, okay, task times to this range. Again, look, when I click on this, the name is not task times, but when I select all of them, you can see the name is task times. And if I click on this name manager, you can see all the names that we have already defined here. And here I write again task times. And finally, I need to define this precedence relationship, and this precedence relationship is a matrix of 0 and 1, so I don't need to define it as float. You can define it, but it's not necessary. It is just integer values. So I need to define this B. But if you look at our model over here, this B is a matrix. So it is BJK. You can see the use here, BJK, and both J and K are the tasks. Okay, precedence relationship between task 2 and task 4. So it means that I need to define this B with the first index being tasks and the second index also tasks. And this should go from we should read this data, or we will read this data from Excel again. By the way, again, as I said, there are different methods to define it. Sometimes you can use, if you like, J in tasks, okay, but it's not a necessity. You can just use tasks and avoid this J in tasks, because in the model you can use any index. You don't need to just use J index for tasks. Okay, you can use I, K, any index. Therefore, it's not necessary to do in this format, but I just wanted to show that it is also possible. Okay, now let's read this two-dimensional array from the Excel. Again, we go to this data file, and in this data file I will write B, and it is from, I will just copy this part, it is from, look, this time this B is in this second sheet, which is data 2. Okay, so I'm going to write here data 2, this is the format, and it starts from B4, so B4 up to, it goes to M15, and this is very important. This is a very critical point, and many new learners make a mistake at this point. What is that mistake? You see, we are defining this B to be from tasks to tasks. And how many tasks do we have? In this question we have 12 tasks. So this matrix should be 12 by 12. Okay? And here, when you write this range, then this range should be 12 by 12. Otherwise, CPLEX will give you an error. But that error will not be given at this point. So if I just write, for example, instead of this 12 by 12, if I use this 14 by 14 and define my array from B4 to L14, okay, instead of M15, if I write L14 here, you see CPLEX will not give you an error message. The error messages that we have while implementing the model is due to the syntax. And after that, when you finish writing it, when you click on run, you will get some error messages which are related to these now parameters, the values that you use, and etc. Okay, so currently here we define a matrix which is 11 by 11, but in fact in reality it should be 12 by 12. Most probably in this case you will not get an error message, but this last part of the vector will be assumed to be 0. Or maybe you may get the error message, but on the other hand, if you define a vector to be 12 by 12, but if you try to read it, for example 13 by 13, a larger one, then you will definitely get an error message. Therefore, it's very important, very critical to define these arrays in the correct size. And again, you don't need to write it in this way, but instead we can just define this range, two-dimensional range, as a name, and I will write it as precedence. Okay, so we define this array, we gave this the name precedence, and now instead of this notation I will just write precedence. Okay, so this is how we read from the data file. Let's come to this model file again. So we define number of tasks, number of stations, we define the task times, and we define the precedence relationships. And these ranges are necessary to define task times and precedence relationships. And now we are ready to define our decision variables, if you look at this model over here, the decision variables are xji and tc, and this ji is like this. If task j is assigned to station I, so it means that this first index j is for tasks and the second one is for stations. Okay, so here I am going to define decision variable for which the command is var, and this is a boolean 0-1 decision variable, binary decision variable. So var boolean, its name is x, then it has two indexes. The first one is tasks and the second one is stations. Again, a mistake that the students or new learners usually make is here you need to write the range. Okay, some new learners write n tasks here, and n tasks is just 12. It is not a range, it's a value. Okay, so you cannot write a value here. You need to write inside these parentheses to define arrays or vectors. You need to write either ranges or sets. And we have one more decision variable, which is the cycle time, and it is a float decision variable. But what kind of float? It's an unrestricted float. No, the cycle time can only take values of positive. Of course, we need to write the indicate that this is a decision variable, and it takes continuous values, real values, which are positive, and I will name this as TC. Okay, so we completed the definition of our parameters and decision variables. Now we are going to implement our model. Again, let's have a look at our model. We will just implement this part. When you correctly define your parameters and decision variables, implementing such a model is very easy. Basically, if you understand the notation, you are writing exactly the same thing, okay, with the syntax of CPLEX. Okay, so what are we going to do is we are going to minimize. I think it should be lowercase letters, because you see, when CPLEX understands a command, it turns its color to blue, and it's case sensitive. So if I write it in lowercase, you see it's now turned to blue. We are minimizing our objective function, which is basically TC. Okay, then in order to start writing these constraints, by the way, you can leave any empty space. If you like, you may not leave, you can write to every line, but if you like, you can leave such empty spaces, and the empty spaces are just ignored by CPLEX. So I will write minimize TC subject to. Okay, so this indicates the starting of the constraints, and the constraints should be written within such curly brackets. Okay, so first constraint that we will write is this TC greater than or equal to the summation j from 1 to m. And look, when you are writing such a constraint in compact form, first look at this right hand side. This right hand side tells how many constraints you are going to write, and you are going to write for which variable, which index, and this index is the index for stations. So we are writing this constraint for all stations, and basically we will say it for all, and then what index do you want to use for these stations? And I want to use I index, because in my compact form here I am using index I to indicate stations, but you can use anyone. You can use J, you can use K, you can use any letter. Okay, but I am going to use I, and it is the stations. So I am writing a constraint for all stations, and for the stations I will use the index I. Okay, then what do we have? We have this TC greater than or equal to. So TC basically greater than or equal to is written in this way. And then on the right hand side, what do we have? We have summation over all tasks. You see, this is summation. and the keyword for summation is basically sum, and in this for all statement over here, and in this sum statement, you see we write the values inside this parenthesis. So summation over j index, I want to use j index, j in tasks. Okay, so you can, if you used I index here and if you use another I inside here, it will make a confusion. The problem will not work correctly. Okay, therefore be careful with these indexes. And I'm taking this summation of what? Tj, task time, multiplied by xji. So basically this is t. Now when I define this I index and j index and their values, then I can just use them as they are, tj, and multiplied by x, and indexes are written in these brackets, xji. Okay, so this is the first constraint, that's all. And as I said, when you understand this notation, it's very easy. This epsilon summation or sigma notation here is sum j in tasks, and this right hand side over here, I from 1 to n, is this for all here, and the rest is the same. Let's have a look at the second one. So I need to write a constraint for all tasks. Okay, so again I'm going to write for all, and I want to use j index. So if you use the same index for the same, to denote the same thing throughout your model, it will be easier. But of course here, if you like, you can use I in tasks. Initially we used I in stations, I for stations, but in this one I want to use I in tasks, and it's perfectly fine, but it will make confusion for yourself when you are reading it. So it's better to use the same index for the same purpose throughout the whole model. So I'm going to use for all j in tasks. Let's see, what do we have? So summation over all workstations. So sum I in stations, and what do I want? I want this to be equal to 1, and equal to in CPLEX is written as double equal to 1, and the right hand side of all constraints should be equal, should be finished with the semicolon. But of course I forget something here. Summation of what? Summation of xji. So I need to write here x, j, and I. And also you see the multiplication in CPLEX is this sign over here, which is asterisk. If you don't write it, it will give you an error message. You see, you can see the error messages in this problems tab. It says syntax error, and also if you come over this error notation, you will see there is a syntax error. So we should write here this multiplication, which is asterisk. Okay, so this is the second constraint, and now let's use the third constraint. Let's write the third constraint, which is we are writing for all j and k. J and k are tasks. So it's the same for all j in tasks. Okay, and you can write like this, for all k in tasks. This is correct, but in fact you don't need to do it. You can write these multiple for alls inside the same one, and you can just say for all j in tasks, this comma, and k in tasks. If you have others, you can add all of them to here. And sometimes you see we may have some conditions on these indexes. They cannot take these values, they should be greater than this, and etc. If that is the case, for example, let me write an example here. If you want to write this summation let's say over for all j from 5 to 10. Okay, so j is defined from 1 to 10, but in this summation you want to take it from 5 to 10. Then how do? We write sum j, let's say in tasks, and then we put this sign which tells you that there is a condition, and you say this j is greater than or equal to 5. So it will use all these tasks which is 1 to 10, but under this condition this j should be from 5 to 10, so it will take the sum from 5 to 10. Okay, so although here we have not written a condition, you may just say that okay, j and k, for all j and k we are writing, but j is different than k, because if j is equal to k, it means that we are searching for the precedence relationship of a task with itself, which is 0, which is not meaningful. Okay, you can just ignore that one, and if you want to do it, you can just put this j is not equal to, is written in this way, not equal to k. Okay, so this is how you can write a condition on these indexes. And what do we have here on this left hand side? It is summation. Okay, so summation over all stations I in stations, right? And as you see here, it is I times xki. So I times xk and I, and it says that this should be greater than or equal to bjk times, so greater than or equal to bjk times, and we have this summation again from stations, summation, again you need to be careful with the parentheses as well, I in stations, and then I times x j I. Okay, so this is the end of this constraint. We have written 3 constraints, and what else do we have? You see, we have this xji should be 0, 1. This is the sign restriction constraint, but you don't need to write it here because it is already here. While defining these decision variables, we define their types and their values. So this x is Boolean, which means it takes values from 0 to 1, and this tc is float, which means that it takes values greater than or equal to 0. Okay, so I guess this is the implementation. We implemented this model, and now we can make a trial. And you see, we have this data file, we have this model file, we have this Excel file, and we have this run configuration. And currently you see there are no syntax errors, so that no messages are given to us in these problems. We are ready to try it, but of course when you try it, you may sometimes you made some small typos, mistakes, or mistakes related to these ranges. You may get some error messages. Don't be afraid from these error messages. It's always the case while you are implementing a model, but then you need to understand what is wrong and you need to correct it. Okay, so in order to run this, just right click on this configuration, anywhere on the configuration, and click run this. And when you run it, you see there is this launching. You can follow the launching, and you can follow what's going on with the model in this engine log tab. Okay, you see it's still launching. Usually it doesn't take this much long, but when you read the data from Excel, it's a little bit longer, and currently this computer is a little bit slower. That's one of the reasons. And you see, fortunately we didn't get any error messages. It's all correct, but the thing is, never trust to your model. Your model may be wrong. Although you obtain the solution, your model may be wrong, and you need to check the solutions. You need to investigate the solutions to see if everything is correct. Inside this engine log, you can see this branch and bound solution technique over here, and the solutions, you can see the solutions from here. As you see, the cycle time appeared to be 0.9, and the assignment of these x values are here. You see this that the first task is assigned to second workstation, second task is assigned to first workstation, and etc. And also you can see the same information on the tab here left hand side, which is problem browser. You see the objective function value is 0.9. By the way, when you go to this statistics, you can see several statistics, the number of variables, number of constraints here, and it's important to see this optimal statement, because sometimes CPLEX stops with a time limit or stops with, for some reason, due to some infeasibility, but continues to work on to give some relaxed solution, and then you obtain a value here and you say that okay, this is the optimal solution, but in fact it's infeasible, it's the relaxed solution. So it's important to understand that this solution is optimal. So for that you can go to the statistics after solving and try to search for this name optimal, or also in the solutions tab you see it should write optimal here. If it doesn't write optimal, then it may be a relaxed solution, there may be another issue with it, you need to be careful. Okay, so here as you see, you can see all the parameters here, especially when you are reading the data from another source, from an Excel sheet. It's important to observe these data to understand if the data is read correctly. And let's have a look. The number of tasks is 12, it's correct. Number of stations is 5, it's correct. And you should look at this t value, which is the task times. And of course it is difficult to maybe read it from here, but when you click on this, you will open the tasks on this editor window, and you will be able to read all this. And if you like, you can just, by using shift and down arrow, you can select all of them and you can just copy these to Excel to modify them or to compare them with the existing ones. Everything seems to be correct. Again, you can do the same thing for this B. You see, you can see 1 and 2, 1 and 3, the B matrix. You can find it here, and it seems to be correct. And when we come to this decision variables, you see that TC is 0.9, and again you can see this X values over here. But again, if you want to see it, you can just click on this and you will see these assignments. The first task is in the second workstation, second task is in the first one, third task is in the second one, and you can just copy all of these into Excel and modify it or save it. Okay, this is the implementation of assembly line balancing problem type 2. I hope this is beneficial. I will make another tutorial to implement type 1 assembly line balancing problem, and also make some analysis on this type 1 problem, solve different versions of the problem.